Imagine this. You're looking up at the night sky and billions of stars are shining. But one of the closest stars to us can't even be seen with the naked eye. Its name is Proxima Centauri. And here's the wild part. This little star has a planet orbiting it that might actually be similar to Earth, Proxima b. So let's start from the beginning. Proxima Centauri is the closest star to our Sun. It's about 424 light-years away. That means even if we could travel at the speed of light, it would still take us over 4 years to get there. With today's technology, that trip would take thousands of years. So yeah, when we call it our neighbor, that's only true on a cosmic scale. Proxima Centauri is what's called a red dwarf star. That means it's much smaller, cooler, and dimmer than the Sun. Compared to our Sun, its brightness is like a candle next to a spotlight. But orbiting this faint little star is a world that fires up the imagination of scientists everywhere, Proxima b. Discovered in 2016, Proxima b orbits its star really close. In fact, a full year there, one complete trip around its star, takes only 11 days. Sounds crazy short, right? But because red dwarfs are so small, even tight orbits like this can still fall into what we call the habitable zone. And what's that? Simply put, it's the sweet spot where liquid water could exist on the surface. Not so close that it all boils away, not so far that it's frozen solid. Proxima b sits right on the edge of that zone. Think about it. Just a few light years away, there could be a planet with oceans. But of course, it's not that simple. Because Proxima b is much closer to its star than Earth is to the Sun, it feels the full force of the star's quirks. And some of those quirks are tough to handle. So here's what you need to know from this first part. Proxima b is the closest Earth-like candidate we've ever found. But at the same time, it's also one of the most debated when it comes to whether it could really host life. In the next parts, we'll dive deeper into its mysteries. Don't miss what's coming next. Hit that subscribe button. Now let's talk about how this mysterious planet was even discovered. Because finding a tiny planet orbiting a distant star, one we can't actually see with our telescopes, is no easy job. Proxima b was discovered in 2016 using something called the radial velocity method, or the wobble method, if you want it simpler. Here's how it works. When a planet orbits a star, it doesn't just move around smoothly. It tugs on the star, making it wobble ever so slightly. We can't see the planet directly, but we can detect this wobble in the star's light. When the star moves toward us, its light shifts a little toward the blue end of the spectrum. When it moves away, the light shifts toward red. By carefully measuring these shifts, scientists realized there had to be a hidden planet out there. And that's how Proxima b was revealed. Detecting this around a faint star like Proxima Centauri wasn't easy. It took incredibly precise measurements. Scientists spent years watching the star with giant telescopes in Chile at the European Southern Observatory. And finally, they noticed the star wobbling on a perfect 11-day cycle. That was the clue, an orbiting planet. The excitement only grew when the numbers came in. Proxima b is about 1.17 times the mass of Earth. In other words, it's practically Earth-sized, which makes it very likely to be a rocky planet. That means it could have a solid surface like Earth or Mars, maybe even mountains, oceans, and an atmosphere. But here's the catch. We haven't actually seen Proxima b. All of this comes from the star's wobbles. So, we don't yet know if it has an atmosphere, water, or if it's just a dry rock. Still, the data we do have puts it high on the list of potentially habitable planets. So here's the takeaway from this part. Proxima b isn't just a discovery. It's proof of how far our technology has come. Humanity managed to uncover a hidden world by reading tiny tremors in starlight, and that alone is pretty amazing. Proxima b's most interesting, and also most intimidating, feature is how close it is to its star. This planet orbits Proxima Centauri at just about 7.5 million kilometers away. For comparison, Earth is 150 million kilometers from the Sun. So, Proxima b is about 20 times closer to its star than we are to ours. Here's the kicker. Proxima Centauri is much smaller and dimmer than our Sun. Despite being so close, the surface temperature of Proxima b might still be within the range where liquid water can exist. That's why it's considered to be in the habitable zone. But there's a major problem. This close distance likely means the planet is tidally locked. That's like the Moon with Earth, always showing the same face. So one side of Proxima b is always facing its star, and the other side is in constant darkness. On the star-facing side, temperatures could be scorching hot, while the dark side might be freezing cold. The only place that might be suitable for life is a narrow twilight zone between the two extremes. If the planet has an atmosphere, it could help balance temperatures and create more stable conditions for life. But without an atmosphere, one side becomes a fiery hell, the other a frozen wasteland. Then there's Proxima Centauri's nature. Being a red dwarf, it's known for frequent flares that release intense radiation. If Proxima b doesn't have a strong magnetic field, this radiation could strip away its atmosphere, and without an atmosphere, life as we know it would be nearly impossible. So in short, whether Proxima b can support life remains a huge mystery. It looks promising on paper, but there are plenty of real-world obstacles. Just imagine, if we could somehow land on Proxima b, what would we encounter? This is where it becomes a complete mystery. Because we have nothing but the light data coming from telescopes. But scientists can make some predictions based on what we know. Proxima b's mass is slightly larger than Earth's. This increases the likelihood that it is a rocky planet. So it is most likely not a gas giant, but has a solid surface like Earth or Mars. But what would this surface look like? A barren and dry desert? Or a blue world covered with oceans? This depends entirely on its atmosphere. The atmosphere is critical. If Proxima b has a thick atmosphere, it could balance the planet's temperature, block some radiation, and even carry heat to dark areas via winds. This could create more favorable conditions for life. But what if there is no atmosphere? Then the planet's day side would be a scorching lava pit, and its night side a frozen tomb. So, could water, the most important thing for life, be there? If the planet had volcanic activity in its past or was bombarded by icy asteroids, water could exist on or beneath its surface. Perhaps there are giant glaciers on the dark side. Perhaps liquid water lakes are hidden in the twilight zone. But there is a major risk here. Proxima Centauri's powerful flares. This star can emit such intense radiation that it may have stripped away and destroyed Proxima b's atmosphere over millions of years. If that happened, what remains could be a bare planet completely inhospitable to life. In short, Proxima b could be a beacon of hope or a source of disappointment. For now, the only thing we know for certain is that it remains one of the most exciting candidates in the search for life beyond Earth. After all, we can't go and see a world 4.2 light-years away for ourselves. All we can do is carefully examine the light coming from the star. So how does this work? First, telescopes come into play. From old giants like Hubble to new-generation observation tools like the James Webb Space Telescope, they all analyze the star's light. If Proxima b has an atmosphere, the light from the star leaves clues as it passes through that atmosphere. For example, water vapor or carbon dioxide molecules absorb light at specific wavelengths. Scientists can see these gaps and predict what gases might be present in the atmosphere. But it's not just about the atmosphere. Because Proxima Centauri is a very active star, telescopes also record these flares. This allows scientists to try to calculate whether Proxima b's atmosphere could survive. Now think about it. When the James Webb Telescope focuses on this tiny dot, It's actually trying to produce a weather report from billions of kilometers away. Are there clouds? Is there water? Or is it just a bare, dead rock? Of course, the research doesn't stop here. Ground-based telescopes are also involved. Giant eyes like Europe's Very Large Telescope, VLT, or the soon-to-be operational Extremely Large Telescope, ELT, are preparing to see Proxima b more clearly. The goal is to take a direct photograph of this planet. When that day comes, humanity will see the true face of a rocky planet outside the solar system for the first time. That moment will be a historic turning point in the search for extraterrestrial life.